Now you're gonna see that today with power rule that your derivative process is going to become a lot faster, a lot easier to do. The negative about this is that it's more efficient, but we lose that visual connection with slope formula. But hopefully with that 2.1 limit definition, we're kind of understanding that, okay, our derivative process is just a slope formula that has more variables in it, right? And but once we do power rule, we're going to let this be the foundation, and it's going to carry us through the rest of the semester. So we're largely going to leave that limit definition behind, except for us to continually remind ourselves that anytime your derivative process feels too complicated or too abstract, it is just slope, right? It is just a way to create a slope formula for some curve, some graph. Okay. So, okay, let's see that. Okay, so before we get into power rule, let me talk about constant rule. This rule says that if a function is simply a constant, then the derivative is always going to be 0. Okay, so to help make it more concrete, think of a constant as just a horizontal line. Right, any constant is just going to be a horizontal line. And what is the slope along a horizontal line? 0, right? There's no steepness to a horizontal line. So that horizontal line could be at 5, it could be at 10, it could be a negative 0.75. Any constant is the horizontal line. Any horizontal line has slope 0, so that's why the derivative is 0. So I'm going to keep reminding us that derivative sounds abstract, but you can always replace that word with slope, and all of a sudden that becomes a lot more concrete, right? We know what slope means. We know what it feels like. We know what it feels like to walk on a slope 0 versus a steep slope, right? Okay. So now power rule are for functions that have a degree that's other than 0. Okay. So if I have a function that is x to the nth power, then the derivative, right, the power rule is going to be n times x to the n minus 1. So what that means is that exponent that we're staring at the beginning comes down in front as a coefficient, and then we subtract 1 from the original exponent. Okay. So we bring the exponent down in front of the variable, we turn it into multiplication with the variable, and then we subtract 1 from the original exponent value. So an important note is be sure that the function is in appropriate form before applying power rule. And there are 3 things. 3 conditions that we have to make sure that we are have in place before we do power rule. So the first is convert any radicals to rational exponents. So if I have square root of x, what's the rational form of that? X to the 1/2. Okay. All right, so any radicals, you want to get it to be a rational form. Second, you want to move all the variables from the denominator to the numerator. So power rule does not work for variables in the denominator. Okay, this rule that you see here is only going to this bringing down the n and subtracting 1 from the exponent is only going to work if the variable is in the numerator. So if something's in the denominator, we have to get it to be in the right place. And the third thing I forgot to put down for you guys is we need to expand all terms. So in other words, no parentheses. So if you see parentheses in the problem, We can do derivative process for that problem. We just haven't learned about it yet. But if we want to do power rule, we got to resolve all parentheses, okay? If there's parentheses in the problem, chances are that means it's not ready for power rule. Okay, so let's do one example here and to kind of practice this process, but then along the way, I'm going to keep reminding us that we need to check for all three things and take care of all three things before we do power rule. Okay, so first, y equals x to the 7th power. Okay. All right, so if I want to find the derivative, I need to make sure all three conditions pass. Do we have any radicals to convert? No radicals, so we're good. We need to move all the variables from the denominator to the numerator. There's no issues there. And then we also have no parentheses, so we're good. Okay, so to find our derivative, we can say y prime is equal to. Okay, so power rule, we're going to bring the exponent down in front. So that 7 is going to now get pulled down in front of the variable. And then what do we do with that exponent? -1. So 7 minus 1 is 6. So it's a lot more efficient, a lot faster than having to go through the limit definition and do f of x plus h and all that. We're able to get directly to the derivative a lot faster. Okay? But we do lose that connection with slope formula, right? But hopefully we just continue to remind ourselves that derivative is a slope. So whatever this curve looks like, this derivative is going to do the job of telling us the steepness of every point on this curve. Okay. Okay, any questions? Okay, part B, g of x equals cube root of x. Let's go down our conditions here. Convert radicals to rationals. We do have to take care of that. So how can I rewrite this cube root of x?
X to 1/3.
X to the 1/3. Yeah. Okay. Variables need to be moved from the denominator to the numerator. That's not an issue here. That's already in a good spot. And then expand out terms. Okay, parentheses, that's not an issue either. We can leave that alone. So we should be ready for power rule. So let's go through power rule. So g prime of x equals. Okay, first, what do we do with that 1/3? Okay, bring that down in front into the multiplication problem. And then we subtract 1, but we got to do common denominator. So subtracting 1 is same thing as what? Minus 3/3, which is
Negative 2/3.
negative 2/3. So that's the derivative. But I'm going to ask you to do some cleanup. So what I mean by cleanup is once you have arrived at your derivative or at your answer, if you have any negative exponents left, you want to resolve the negative exponent. So right now, this x is sitting in the numerator. To force that negative to be a positive exponent, we're going to force that x down to the denominator. So g prime of x is equal to 1/3x to the 2/3. So we'll make that x share the same space as that 3. Or if you want to convert it back to radical form, that is fine as well. Either is fine.
So whenever we get a negative in the exponent, we need to convert it.
Yeah, anytime you have a negative exponent anywhere and you're sitting at your derivative, go ahead and just move it. Yeah, move the variable to the other side to force the negative to the positive exponent. But I mean, I would say in the grand scheme of things, it's a minor thing. Okay, it's not a major thing, but just for my preference, I want positive exponents.
And would it be acceptable to leave it in that fraction exponent?
Yes.
Okay.
Yeah, that's right. So rational or radical form is fine at the end. Your AP exam is never requiring you to rationalize the denominator, so you can leave your answer in radical form and in the denominator. That's fine. Okay, part C, I want to find the derivative for y equals 4/x to the 5th. Let's go through our conditions, radicals to rationals. That's not an issue. We can leave that alone. What about variable from denominator to numerator?
Yes.
Yes, we got to take care of that. Okay, so the temptation is leaving that x to the 5th down there and just doing the derivative and calling it 5x to the 4th. Okay, but power rule is just not going to going to work, it's not meant for the denominator, okay? It's only meant for the numerator, so we have to rewrite it to the point, to the place where Power Rule can actually handle this problem. So when we bring that x up to the top, what does that become? Yeah, 4x to the negative 5th. So now everything's in place, right? No radicals, no variable in the denominator, no parentheses. So now we can do Power Rule. Okay, so derivative, what do you think? What do you think is going to happen with that negative 5s? Good. It's going to multiply with any coefficient that's already there. So here the negative 5 will come down, multiply with the 4, negative 20, x to the what? Subtract 1 from the exponent, negative 6. That's the derivative. That's fine, but I am going to ask you to do some cleanup. So what will my cleaned up derivative look like?
1 over.
So is the negative 6 going to see the negative 20? No, it's only for the x. So the negative 20 stays up top. It's only the x to the 6 that gets brought down. Now, if the negative 20x is in its own set of parentheses, the negative 6 is outside, then we'll go ahead and move that negative 20 down. But that negative 6 is only seeing the x. So we only need to bring the x down and leave the 20 above. Okay, any questions? Okay, part D, you see multiple terms separated by plus or minus. And when you see this instance, you really can treat this as 4 individual problems. It's just 4 individual problems that happen to be connected by plus or minus. So what we're going to do is we're going to just wait and rewrite each term until every term is ready for Power Rule. And then we do the derivative process all at once. Okay. What I prefer not you do is you take the derivative of one term and clean up the other term. Then if everything is not lined up, it's hard to go back and for you to go back and check your work because you don't know, wait, did I take the derivative here already? Or am I ready for my, am I still cleaning up? And you want to just, even though it does feel redundant because you're having to rewrite your term that's already ready for Power Rule, it's easiest and cleanest to just wait until every term is ready. So we can obviously tell that not every term is ready, but some are. Okay, 8x to the 2/3, is that ready for Power Rule? Yes. It's ready, but I'm not going to do Power Rule just yet. I'm going to wait until every term is ready. So I'm just going to copy that term down, y equals. Okay, 5th root of x. Right. I do need to do a little bit of cleanup. So what can I do with that 5th root of x to get it ready?
Negative x to the 1/5.
Yep, x to the 1/5. Plus 2 over root x. There's 2 issues here. What are the 2 things we need to take care of?
There's a denominator and it's a radical.
Yeah, denominator and radical. So radical to rational, and then we got to push that variable to the top. So right now you can think of it as 2 over x to the 1/2. And then we can bring that x up to the top, make it 2x to the what? Negative 1/2. And then that 0.875 is the constant. So I'm going to just rewrite it because I don't want to take the derivative of one thing and leave the rest alone. Okay. So now every term is ready. I can do Power Rule for each term. Okay, so y prime equals. Okay. Bring that 2/3 down in front. How is that going to affect the 8? Multiply, so 16 over 3. And then x to the, good, you subtract 1, but match the common denominator there, so negative 1/3. Minus, bring down the exponents. What's my new exponent?
A 1/5. Or no,
Minus,
negative 4
good,
over 5.
minus 5 over 5. 1 minus 5 is negative 4. Okay, keep going, bring down to negative 1/2. What's my new exponent? Negative what? 3/2. And then what's the derivative of 0.875? Good. First thing that we learned, right? Any constant is just a horizontal line. Any horizontal line is a slope 0, so therefore my derivative of a horizontal line is always going to be, of a constant is always going to be 0. Okay, let's do some cleanup. I want to resolve that negative exponent. I'm going to push that x down to the bottom. It's going to sit next to that 3. Bring that x down, make it sit next to the 5. Minus 1. Okay, any questions there? Yes.
Was you ever have to put those denominators together?
No, you mean like finding common denominator with all this? No, you don't have to do that. Yeah. Yeah, so now before we move on, I want to do 2 more things here. We'll see if I can squeeze this in here. So parts E and F. What if I just gave you 9x? What's the derivative of 9x?
Negative 1 in the exponent.
So let's go through power rule here. So there's a hidden 1 there. So what happens? Yeah.
0.
So y prime is equal to 9. Because we got to bring down that 1, right? So 1 times 9 is 9. 9x to the 0 power. Anything to the 0 power is what?
1.
1. So that's going to leave us with what? Just a 9, right? So y prime is equal to 9. So if I have a linear, that is just going to give me 9. Now, this is something that we can do with power rule, but we can also do this without calculus. Why is that? Because this is a linear function, right? Y equals 9x, the same thing as y equals mx plus b. And the m, what's the slope? What's the m of this linear function?
9.
9. Right? So any linear graph is going to have a slope of that coefficient. So we can either rely on power rule to get to our slope, or we can rely on mx plus b to understand that, oh, that's just, I don't need calculus. I just understand that if it's x to the first power, my slope is, this is just going to be a slanted line. That line is going to hold the same slope all the way through. It's going to have a slope of 9. So typically we do power rule for anything that is other than 0 or 1. And if it's something that's the 0 power, then I know it's a constant. The constant is always 0. So if it's a linear, I can do it through power rule, but typically we just understand that anything that's linear, we can just remove the x and whatever number is in front, that's the slope, that's the derivative. One more thing I want to squeeze in here, part F. Y equals 2 over 3x squared. If I want to find the derivative, what's out of place? Okay, so what would that look like after I make the adjustment? So what needs to be moved? The x. What does not have to be moved?
The 3.
So the 3 stays. Because I can move the x without having to move the 3, right? Because the squared is not impacting the 3. So this is just really 2/3 x to the negative 2. Right. So even though the 3 and x are next to each other, they're not connected to each other. I can move that x without moving that 3. So now I can do the derivative, right? So now everything is in its right place. Y prime, bring down the negative 2, multiply by the existing 2/3. What's my new exponent? -3. So now that I have my derivative, I can do some cleanup, bring the x back down to the denominator as in our cleanup stage. Any questions so far? Okay, so we're gonna keep building. Next page. Okay, if f of x equals x to the -2, find f prime of 2. All right, let me talk about what that means. This f prime of 2 means find the slope of the function at x equals 2. Okay, that's what that notation means. But what it also means is that this is going to have to be a two-step process. We first have to find the what? Derivative function, and then we can evaluate the derivative and find the slope. So we need to first find f prime of x before we can find f prime of 2. So we don't want to try to do this all in one step. So let's find f prime. Do we have to do any cleanup for this before we do power rule? Everything's ready, right? Radical, there's no radicals, there's no denominator variable, and then there's no parentheses. Okay, so f prime. Power rule becomes what? -2x to the -3. Okay. Subtract 1 from the exponent. Do some cleanup. Again, we move the x, but the -2 is not going to go anywhere. It's going to stay up top. So now that I have my slope formula, I can figure out the specific slope at a specific point. I want to find the slope of this function at 2. I'm going to rely on the derivative to help me get there. So f prime of 2 equals, so just replace every x in the derivative with 2. -2/8 reduces to be, yeah. Okay, number 3, you're going to see this type of problem a lot. So every time we introduce a new derivative rule, you're going to be asked to find the tangent line equation. So tangent line equation, we always want to do 3 things. Okay, first, we always want to find the point. Second, you're going to find the slope. And then third, you're going to build your tangent line equation, which is point slope form. That's the easiest one to get to. Okay, so first things first, how can I find a point? I have the x value. So how can I find the y value? Back into the what? Original, right? The original is going to give us a location, give us a y value. Now, typically, when we see this, I think the tendency is we want to square that 8 first and then take the cube root, which is fine. But I mean, we're having to do some of these problems without a calculator. We're going to want to do this. We can rearrange that process and think of it from this perspective, right? Why don't we cube the 8 first, cube root the 8, get that number smaller, and then if I raise to the higher power, it's easier, right? It's easier to do this than trying to create a large number and then figuring out what the cube root or the fourth root is. All right, so what's the cube root of 8? 2, and then what's 2 squared? 4. So even though it looks like I have to take that exponent before I take the radical, it doesn't matter. The order doesn't matter. So you want to pick the order that's going to be easier to do, especially without a calculator. So take the cube root first, and then get the number smaller, and then it's easier to raise it to a higher power. Okay, 2 squared equals 4. So we have our ordered pair. The next step, I need to find the slope, but to find the slope, I have to first find the derivative, right? I gotta go through the power rule. So let's do some cleanup here. F of x equals cube root of x squared. What's the rewrite of that term? X to the
1/3.
2/3 to the 2/3. Yeah. Okay, so the number to the right of the variable is going to be in the numerator, and then the root, the number in the root position is going to be in the denominator of your exponent. Okay, so now we can now find the derivative. Bring that exponent down. Subtract 1 from the exponent. Match that common denominator there, so negative 1. 1/3. Do some cleanup. And now I'm ready to insert the 8 into the derivative so I can find the steepness or the slope of this graph at 8. Okay, what's the cube root of 8? 2. So 2 over 3 times 2, 2 over 6. And reduce to 1. That's my steepness, that's my slope at that point. Okay, I have my ordered pair, I have my slope. Now I can just put into point slope form. Even though it looks like you can continue further and clean it up, you don't have to. This is acceptable in the AP exam, point slope form. You don't have to get it to slope intercept form. Okay, any questions for 3? Okay, let's look at example 4. Now, example 4, what is standing in the way from us being able to apply power rule? That root x. But the problem is that root x is impacting every term in the numerator, right? So I can quickly convert that to x to the 1/2, but we know that that variable is out of place, right? We can't do power rule with that variable sitting there. So we can bring it up, but I typically find that we miss things when we bring it up because we forget that it impacts every term. So my suggestion for this problem is go ahead and split up into individual fractions, and that way you're forcing yourself to remember that that denominator is going to have an impact for every numerator that it sees above it. So I'm going to rewrite into numerator denominator. And then once I can split up into 3 individual fractions, I can then try to do some cleanup individually, and I can really treat them as individual independent problems. And it becomes a lot easier because we can kind of just kind of divide and conquer a little bit. Okay, I need to adjust that third term. 4 times cube root of x, how can I rewrite that?
X to the 1/3.
So now we're able to see, okay, it feels a little bit better because now I can work towards power rule because each term is now independent of each other. They're not connected like before. And now, but all those x's are still out of place, right? So I gotta bring all those x's up to the top. But this is no derivative yet. We're just cleaning up here. So what happens when the x comes up? It becomes what? X to the -1 half. Okay, we're still in the cleanup stage because we can't do power rule until all those x's are merged together. So how can I, what do I do when I want to multiply bases together? Add the exponents, right? So if I think in terms of common denominators, 4 minus 1 half, the same thing as 8 halves minus 1 half.
7.
7 halves. 2 minus 1 half, the same thing as 4 over 2 minus 1 over 2. And I'm not going to do this yet because 1/3 and 1/2, I have to find common denominators. We're using 6 for both, right? X to the 7 halves minus 3x to the 3 halves. And then after I cleaned up that, the last one is more difficult because I gotta find common denominators that's different from either of those denominators. So 2/6 minus 3/6 becomes -1/6. Now I can do my calculus. So everything up to this point is just algebraically trying to get to the point where I can hand it over to power rule. Okay, so now f prime. Okay, exponent comes down. Now it's the calculus portion. What's my new exponent? Yeah, because I'm subtracting 1. Okay. Bring that 3 down in front, 3 halves down in front, sorry, 3 halves times 3. Do some cleanup process and merging some of these coefficients together. Four 6 reduces to be 2/3. And I'm also going to take care of that negative exponent by bringing that variable down. Okay, any questions here? Okay, example 5. We want to do power rule, but what's standing in the way? Parentheses, right? So we have to get rid of all the parentheses before we can do power rule. So how would you start this process?
You expand that.
Yeah, good. So deal the parentheses first, and then we can work into 3x, right? We don't want to distribute 3x first because order of operations doesn't allow for us to do that. So we're gonna take care of that x plus 1 squared first. expand. Now, when you expand, you still have one set of parentheses left, which you will take care of with that 3x. So now it distributes. So now it's nice and clean, right? No parentheses, no radicals, no variable exponent, no variable in the denominator. So now we can hand it over to power rule to finish it off. 3x cubed becomes what?
I next to the second.
Okay,
squared.
plus 6x squared becomes 12x. And what does 3x become? 3, yeah. Okay. Any questions with 5? I want to do some examples, but before we jump into that, I just want to do a quick review of converting from radicals to rational. Okay, so again, how would you rewrite square root of x to turn it into rationals? X to the what? 1/2. Okay, let's explore that a little bit. Where's that 1 coming from and where's that 2 coming from?
The x have a 1 on it.
Hmm?
Write it.
The exponent, the number to the right, is a 1. If it's hidden, then you know it's 1, and that's going to go in the numerator. And then the 2 is for the square root. That's the hidden number here, right? So that's why it's 1/2. So how about this one here? X to the 1/5, right? So if you forget what the order is, start with this, right? Because you know square root of x is x to the 1/2, and just convince yourself where these numbers are coming from, and then you can, if you forget, wait, it's a 1/5, or it's a 2/2, or it's a 2/5, you can always help yourself by looking at this, what you know, and use that to help build any part that you have a gap on. Okay, how about this one? Sorry. X to the 7/2. Okay, put a star next to this one. This is the one that a lot of students miss, with good reason. But I want to point out that it's easy to miss this one because of it's just harder. It's just easier to get thrown off by something like this. Now, the 7 is the number on the right, and there's a hidden 2 there. That's why 7/2. What are some common mistakes that you think happen? I want to point these out in hopes that you don't make these mistakes on the quiz or test. So let's just point out the ones that are wrong so we can recognize it and make sure we don't apply it.
X to the 7th.
X to the 7th. Okay, what else?
X to the 1/7.
X to the 1. That's the most common one. Okay. And the reason why I think a lot of students do this, my theory is that tendency is we think that if we don't see something that we assume it's a 1. And I think tendency is we read from left to right. If you read from left to right, 1/7 makes a lot of sense. So I see that. That's definitely not right. And also I see sometimes x to the 2/7, where students remember there's a 2 there, but forgetting that it's not left to right, it's right to left. Okay. Okay, good. We'll pick this up tomorrow. You guys have some homework tonight, and we'll practice some more with power rule, but we do need to go into particle motion. Or second part of the frequency. Okay, come up and get your phone.
So you can just go down a little bit.
Yeah. Scoot up or scoot?
Yeah.
Oh, that's good. Yeah, I added the track, depending on that side. You have the track,
We can start making those.
essentially adding a positive thing. I got the comment now.
So it's not. It's like split at, it's like. I forgot what word it's split at. It's like rational.
Yeah, capture the flange. Once I do all this, to just get ready for my calculator. Once here, this is my only calculator.
All they do. Yeah, have you looked at these? Yeah. We don't have anything about.
I know the time, there's actually a four, there's actually a 1/2. I was thinking it's station.
That right up there, great.
But if it's this.
Hello. What?